I open the YouTube also. Okay. Okay, fine. Hello everyone. I am Professor Pankaj Biswas. I am now live. So if you have any queries on the course Fundamental of Welding Science and Technology, you can ask me. Yeah, yeah. I open the YouTube. Fine. Yes, one of the student asked me a question that which module is important uh, for the end semester exam. That means for the final exam. Here, one thing you should keep it in mind. Actually, this is a course where every module is important. That you can say. So the weightage of each module you can say is equal. So you should not avoid any modules. So that generally, I think there are 8 modules. So there will be 8 different portion of question based on if you have any question, you can ask me. I can explain this question here in screen also, because I have a writing pad also. If you have any question by writing also, I can explain the details. Actually, in last session, one of the students asked me a very important questions that is related to DCEP and DCEN. That means direct current electrode negative, and another one is direct current electrode positive. So this question was asked one of the student. He was asking, sir, what is the difference between these two? So last class itself or last session itself, I explained this thing in details. Today also I am planning to explain these things if you want. As there are no other question here what I have seen, that's why I am explaining again here. So for that I am sharing my screen. Yes. So here you can see. So I'm going to explain this, what is DCEP and DCEN. DCEP means direct current electrode. You know this thing because I have explained this. Electrode positive and DCEN means direct current electrode negative. So let us consider this is the workpiece where we want to do the welding. That means this is, okay, I am writing is base material or workpiece, and this is the electrode. Let's. Now you are very well familiar. Generally, to do the welding, there is required a power source. So power source, one terminal is connected to with electrode, another terminal is connected with workpiece, and this base material, base or workpiece is also generally connected with earthing. That is very well known to you. I am not explaining this thing in details again. So what we used to do, generally the arc is generated in between this electrode and workpiece. This is called arc. Okay. Now you are very well familiar about the physics of welding. There you observe that generally this arc is started and arc is remains sustained in between a gap due to two different processes. One is called emission, another one is called ionization. These two processes you are very well familiar, so I am not going to explain this thing in details. Now DCEP means if the power source is direct current in nature, that way then if this power source one terminal, that means if this electrode is connected with negative terminal, then this is called DCEN. If this electrode is connected with positive terminal of the power source, then it is called, that means if it is positive terminal, then it is called direct current electrode positive, and if it is negative terminal, then it is called negatively connected with power source, then it is called generally DCEN. So you know these things. Each generally if the polarity is opposite, generally opposite polarity attract each other. That is very well known to you. That means let us consider in between this gap there are a generally flow of electron. That is very well known to you. Now this electron is negative charge. So once this electrode is connected with positive terminal, then what should be the flow of this electron in between this gap? So the direction of flow of this electron will be generally towards the electrode side, correct? So what happens? So once this electron flow towards the electrode side due to positive terminal connected with electrode, then what happens? The bombardment of this electron, because once this electron start flowing in a gap, it's gaining high kinetic energy. This kinetic energy one is hit that electrode, then there is occurs some bombardment types of thing. Due to these things, generally in case of DCEP generally 70%, around 70% heat is generated. 70% heat is generated in electrode, whereas 30% heat is generated in case of parent material. Especially I am telling about what it's called TIG welding process, GTAW welding process, that you can say. So in the case of GTAW welding process, it's happened like this. But if the case is opposite, that means in case of DCEN, so in case of DCEN, opposite thing happen. Opposite things happen means that this is your power source. This is your power source. So one terminal is connected with power source, another terminal is connected with workpiece, correct? Now you see, so in case of DCEN, here this electrode is connected with negative terminal. That's why, that means power source negative terminal is connected with electrode. So that's why in this case, whatever the electron flow is there, you know that electron flow will be towards the positive terminal direction. So here the electron flow direction is toward workpiece. So bombardment of electron generally taken place in workpiece region, correct? So as the bombardment of electron taken place in workpiece region, so in case of this polarity, around 70% heat is generated in what is called workpiece region, and around 30% heat is generated in electrode region. This you should keep it in mind. So you are asking this another question that, sir, for which polarity generally is preferable for consumable types of electrode, which polarity is preferable for non-consumable types of electrode. Now you see, if the electrode is consumable type, then you should always keep this thing in mind. You want that means your electrode should melt and it should deposit it. So you want more heat should generate in electrode region, correct? That's why what happens, once you go for consumable types of electrode, then DCEP polarity is preferable. So you can say for consumable electrode, DCEP polarity is preferable, because in this case 70% heat is generated in electrode. Due to this, what happens, this electrode material will easily melt and it deposited, correct? This thing you should keep it in mind. But for non-consumable types of electrode like TIG welding, this is generally what happens, consumable electrode you can say GMAW, or you can say MIG welding, metal inert gas welding. Whereas in case of DCEN, here generally non-consumable types of, generally you can say, there is some exception also there. So non-consumable generally electrode is preferable for DCEN. Like one of the example is GTAW, plasma arc welding. These are the different techniques where generally these non-consumable electrodes are used. What I'm telling, understand? So this was the last week questions. So due to this, what happens, writing pad, absence of writing pads, I could not able to explain it clearly. So that's why today I explain these things clearly. Now, if you have any other question, you can ask me. Yeah, one of you already asked another question. Yes, that is a very interesting question, you can say. He asked, that means, sir, which portion, what should be the portion important for this course? I have already explained these things. That means here there are 8 different modules are there. So each and every modules have equal weightage. This you should keep it in mind. Okay. So here you can say from each module there will be around 10 questions. And it is a MCQ types of exam. So all the question will be based on MCQ, because there will be, I think, 4 different options. Out of 4 different options, there can be one answer correct, or there can be multiple answer correct also. So accordingly, you have to give the answer. And just I am telling, there will be some question based on what it's called, some mathematical calculation also, because in this course I have solved different types of problems on, you can say, physics of welding. Then in case of what it's called efficiency of welding, in case of, you can say, what it's called power calculation of welding. So different portion actually. I have solved different types of problems which are very much important related to welding process. So you should always be ready that, okay, whatever the numerical question types of things can come, or analytical question, or you answer some calculation based question also can come there. So you should be very well familiar about all these mathematics which I generally describe in this course. If you have any questions, till now I have not got any other questions. Okay, you can ask me. Here, I think that means whatever the portion you covered, in this portion, I think you have not got any doubt, because that's why I think you don't have any questions. Again, I am telling, if you are in live, you can ask me question. I can clarify your queries, whatever the queries you have. But one thing you should keep it in mind, this is a very interesting course where you will get most of the very fundamental things related to welding process, related to welding principles, related to welding physics. What I am telling, understand? That's why you see, I think one of the participant is live now. If you have any queries, Lakshmi Shankar, if you have any queries, you can ask me, right? Lakshmi, you can write it in your text box, whatever the queries you have. I'll try my best to respond if you have any queries, right? Yeah, in Excel sheet, another question is asked by, just 1 minute, what's his name? Yeah, Anand Prakash. Yeah, Anand Prakash, he asked me, yeah, he said every one of you are asking what is the important module for the exam. Yeah, I have already explained the things. That means the important modules are all the modules, you can say. So here generally the question, you should have fundamental knowledge on welding. But I am just giving you a guarantee that the portion which I covered in this course, outside of this, generally no question will come. So you just carefully go through the different modules, you will get every question from here on. Hajik Hassan, if you have any queries, bhai, you can ask. Hajik, you can write it in text box. Definitely I can respond, right? Hajik, if you have any queries, you can ask. You are not audible actually.
Hello, good evening, sir.
Yeah, Lakshmi, very good evening.
Yes, sir, very good evening. Sir, I want to know about the stick length.
Yes.
When stick length increases or decreases,
Ah.
and then how proportionally arc length, its effect upon arc length and voltage.
Very
that I
good,
don't understand, sir.
Yeah,
Because
I will
when it is
explain.
increasing, and one, I think you have told that arc length is decreasing.
Yeah, I'll just explain, right? That is a very important
Yes,
question you ask. I'll explain it writing in pad itself. So first of
right.
all, I'll explain what is length of stick out. Okay, that I will explain. So you know, this length of stick out generally used in case of, you have already observed, one is called submerged arc welding process, another one is, you can say, MIG welding, or you can internationally recognized terminology is GMAW welding process. Both are consumable types of welding process, that you can say. So what happens here, generally we use a power shoe to conduct, you can say, power from power source to electrode, that you can say. So that's why you see these power shoes. Inside these power shoes, generally you can say the electrode is passing, correct? That is very
Yes.
well known to you. Very good.
Sir, your
Yeah,
screen is not visible, sir.
yeah. I am just sharing it, right? Then it will be
Yes.
very.
Yes, sir.
I have not shared it. It will be very nice. Thank you. I am sharing it, right? Yeah. Now I think it is visible, correct? So you see this. You can say this is electrode generally is coiled, you can say, in a spool. So from there, generally you see there are some feeder mechanism. Feeding mechanism is there. By this feeding mechanism, generally you see this electrode is continuously fed to the whirlpool region. Correct? Lakshmi, am I audible? And you are?
Yes, sir.
Am I visible? Right? Thank you. Now you
Yes, sir.
see.
Fine. Now it's fine.
Now see, this is called generally the power shoe. You see, this is called power shoe. That you can say. So tip of this power shoe to tip of the consumable electrode is called length of stick out, or LOS. It is generally represented like this. Correct? Now you see, and ahead of this, generally this is called arc. Correct? So here one thing you should keep it in mind. So from power source to this is actually the summation of arc length plus length of sticker. Correct? These things you should keep it in mind. Now you know this according to Ohm's law. Little bit I am explaining fundamental wise because this course is fundamental course. So what we know? According to Ohm's law, we know that resistance is directly proportional length and resistance is directly inversely proportional to cross-sectional area. That is very well known to you. So you see, again, we know voltage is equal to, you can say V is equal to IR. Correct? These things also you know. Voltage is equal to your current into resistance. So here R is called resistance, V is called voltage. So from here itself you can observe that this voltage is, you can say, I into R means here once this R is, you make it equal, it generally becomes like rho L by A. Rho is called resistivity. You are very well familiar with these things, so I am not going in details about all this. So you can say V is equal to I rho L by A. So voltage of anything is depends on what? So voltage is directly proportional to length. So here one thing you should keep it in mind. So say power, again here another thing you should keep this thing in mind. So power, or you can say heat generation Q, you can write as power is equal to voltage into current. Correct? So for a power source, let this is a power source. Okay, let this is a power source which is supplying a constant current. Let's which is supplying a constant current I. So current, let us consider from power source it is constant. So whatever the heat will generate in this arc region, whatever the heat will be generated in this arc region, that is generally dependent on what? That is generally dependent on voltage, or you can say voltage difference in between electrode and workpiece, in between your electrode and workpiece. So whatever the voltage is there, it depends on that. This you should keep it in mind. Now here one thing you should keep it in mind. So voltage, whatever the arc voltage, what is arc voltage? Arc voltage means in arc, whatever the voltage is there, that is called arc voltage. Now in length of stick out region, you can write as In length as stick out region also you will get a voltage that is called VLOS. Try to understand this thing, Lakshmi. I am just explaining these things is it clearly. So you see, so voltage, because voltage means there is a length of electrode which is coming out ahead of this power shoe, correct? So that creates a voltage difference. So that is called voltage due to length of stick out. Now you see, so if this this voltage, again this length of stick out voltage is depends on what? Length of
Arc.
LOS, length of S.
Okay.
Arc voltage is depends on arc length. But what it's called?
Okay. Yes, sir.
Length of stick outs, whatever the voltage is coming in length of stick out region, that is actually voltage in length of stick out region. So in length of stick out region, whatever the voltage is there, that also creates some heat. What I am telling, understand? Try to understand, Lakshmi.
Yes.
So
Yes, sir.
that heat generally act as a preheating. That means whatever the heat is generated due to VLOS, that voltage generally heated this exterior portion. That means whatever the length of stick out there, that preheating types of phenomena is taken place. What I am telling, understand? It hit that portion. Clear, Lakshmi?
Yes, sir.
So voltage, whatever the voltage, so arc voltage is depends on whatever tip of the electrode to workpiece surface. This you should keep it in mind. But voltage, so if arc length is less, your voltage is less. If arc length is more, your voltage is more in arc. What I am telling, understand?
Yes, sir.
So here one things you should keep it in mind. In length of stick out region, if this length is stick out more, then you can say in length of stick out portion electrode. That means this electrode portion will hit more. What I'm telling you, understand? It will hit more. Clear? Clear?
Yes.
Due to VLOS, it will hit more.
Yes, sir. You are not audible, sir.
भाई बाहर से क्यों ला रहे हैं? इनसे ले लेगा ना क्या हुआ? हाँ इन्हीं से लेगा ना तो बोलेगा ना। वो सब इन्हीं से लेगा। वहाँ पे कितने दिएगा? यहाँ पे पाइप भी दो ना।
Pankaj Biswas is currently unavailable. Please leave a message after the tone.
Sir, you are not audible, sir.
हेलो हेलो भाई, मैं ऑडिबल हूँ? हेलो, ओके फाइन फाइन फाइन, थैंक यू भाई। नाउ फिर क्या हो गया? एक्चुअली नेटवर्क चला गया था क्या?
यस सर,
एक
यस।
मिनट एक मिनट आगे। ठीक है भाई, मैं अभी एक मिनट अभी इस मैच पे। हेलो, अभी हो
हाँ
जाएगा
जी
भाई।
सर।
1 मिनट। क्या हुआ फिर से कैमरा का?
स्क्रीन शेयर करेंगे सर आप?
कैमरा का क्या हो गया पता नहीं। ठीक है, it is working. Actually, in laptop that connection has lost, no problem. So what we were discussing about length of stick out and what it's called arc length. So that related things, I think Lakshmi already got the idea. So whatever the length of stick out is coming out, okay, that
Yes.
length of stick out generally, if the length of stick out is more, so in that length of stick out region, your heat generation will be more. What I'm telling, understand? So that so if the arc length is more, then in arc length region, your heat generation will be more. What I'm telling, understand? Clear,
Yes.
Lakshmi?
Yes,
So
sir.
always you should keep it in mind. Higher the length of stick out, at that time generally your arc length is reduced. Correct? So
Yes.
if arc length will be reduced in arc region, you can say your heat generation will be less. What I'm telling, understand? Arc length lesser will be the heat generation in arc. Clear?
Yes, sir.
Lakshmi?
Yes, sir. Fine.
Fine. That is the things. Okay, right?
Yes.
So
Na-
whatever the portion you will consider, that resistance will act as a heat source to generate heat in that region. These things just you should keep it in mind. So length of stick out length will be responsible for generating heat in length of stick out region. Arc length is responsible for generating heat in arc length region. Clear? That is the
Yes, sir.
that is the
Then,
fundamental thing, right? Okay.
right, sir. Right. Sir, then total voltage is sum of this voltage of length
Yeah.
of stick plus voltage of arc.
Yes. This is the total voltage difference between, you can say, power source, that means electrode, what it's called, power shoe tip to workpiece. Power shoes tip
Tip
to workpiece.
to works. Right.
Okay. That has a name, that is called stand-off distance. Clear? That has a
Right.
name. So stand-off distance voltage is the summation of length of stick out voltage plus arc length voltage. That you can say. Very good question, right? Lakshmi.
Right.
So here one thing you should keep it in mind. So higher the length of stick out, then more heat will be generated in that electrode region. So your electrode will act as a preheating medium.
Yes, sir.
So what happens? So you can say higher the length of stick out, more material can deposit easily. What I'm telling, understand? So higher
Yes,
the
sir.
length of stick out, deposition rate increase. But here one thing you should keep it in mind. Though deposition is increasing, but is pores generally reduce. Pores. That's why penetration reduce. That you can say. What I'm telling, understand?
Yes, sir.
Force of that molten droplet is reduced. Okay, that's why what happens, your penetration, depth of penetration through the workpiece is reduced. Okay.
Reduced.
Hajiq, Hassan, tell why if you have any question. Hajiq can ask, you are muted, why?
सर एक जो आपने बताया
Yeah,
था
tell.
about rotile, basic and cellulose type of electrodes.
Very good. In SMAW, shielded manual metal
sir,
arc welding process. Yeah.
I think that was the coatings, all coatings.
Yeah, that you can say. That is generally outer coating composition. Depending upon this outer coating composition, that different names come. What I'm telling, understand? Like cellulosic have more in cellulose composition in your flux. What I'm telling, understand? Yes. Rutile means generally titanium oxide and calcium carbonate types of what it composition is more. Similarly, basic electrode also there, correct? That are the things. Depending upon your some proportion of composition of flux, that different names come. Even metal coated, what it's called electrode also are there, where some portion of that means this flux contains some proportion of metallic powder also. That also I explain in SMAW also. Okay.
Yes, sir.
Yeah.
My question is, how should we select these kind of electrodes?
Very good
For
question.
particular
Now you
process?
see,
Actually,
yeah,
that I forget.
yeah, I am just explaining why. Here, one thing you should keep it in mind. Generally, whatever the different flux cover coated electrode I have already told you, each and every flux cover have some particular of advantage as well as particular types of disadvantage. That means each and every flux have some important features. That things I explained very clearly, you can see. So if you want that also I can show you. So there I have told you, that means for doing generally what happens, very sophisticated types of welding operation, you should use basic electrode. What I'm telling, understand?
Yes,
For generally for low cost types of things, you can use cellulosic types of electrode. But cellulosic electrode, once you will use, there is a problem of carbon monoxide and hydrogen what I've say generation. You see, cellulose is a composition of carbon hydrocarbon. It is a saying these things, you know very well, correct? Cellulose.
yes.
So it's a chain you can say chain compound, you can say hydrogen carbon component compound. That is also I have explained there. Okay. Now you see, so once the cellulosic compound burn, it creates of carbon monoxide and what it's called hydrogen. That hydrogen generally creates some problem that is called hydrogen embrittlement. Okay. So this hydrogen embrittlement act as a cold cracking phenomena in weld. Then also this electrode have some particular application where generally these types of thing, because you can say this cellulosic types of electrode is cost and other things, and it has some special features like you see I have already explained that things clearly over there. But what happens, to mitigate these types of features, generally some advanced types of electrode developed. Second categories I have told you, rutile. So rutile also have some specific features which is not available in cellulosic types of electrode. Correct? Similarly, another categories I told, that is called basic electrode. Each and every electrode have some specific features. Someone can use downhand position, someone can use overhead position, someone can use horizontal vertical position. So each and every flux have some important features that you can see. Because what happens, like cellulosic types of electrode, you can't use overhead types of position. Because this viscous effect and other thing is less.
Yes.
What I'm telling us, you can't use this thing very sophisticated application because there is a chance of hydrogen embrittlement and hydrogen cracking phenomena, that is cold cracking phenomena. So you can't use these things for all the purpose. That's why you see some other, that is rutile means titanium oxide base, what it's called flux is developed. Further generally to improve that quality, some other categories comes. What I'm telling, understand? Nowadays also, depending upon our requirement, lot of research work is going on this flux coating, and we are developing different types of flux coated electrode for different purpose. What I'm telling, understand, right?
Yes.
You can imagine, actually nowadays also we are developing, we are doing research on different types of flux coated electrode for underwater purpose, for very cold weather, cold region, for under what it's called very low temperature area. So depending upon situation, actually what should be the preferable one, that things nowadays also lots of research work is going on. What I'm telling, understand, right? You are very means you have very interesting questions, Lakshmi. Very nice. That means you are going in depth, or you are trying to extracting what is the flaws and other things are there. Very good, Lakshmi. Go ahead.
Yes.
If you have any other queries, you can ask me now also, right? You
Yes,
got
sir.
my point?
Yes,
You
sir.
just
Yes.
go through every features I explain there very clearly.
Yes, sir. Yes,
Like
sir. Very clear.
cellulosic, where is it applied? For which position it is preferable? So then why this basic electrode, electrode is coming? What is its basic features? What is its drawback and all? What I'm telling, understand? Everything you can get. Like this basic feature, generally you can say it's called generally to eliminate this hydrogen effect. You can say low hydrogen electrode, you can say, or hydrogen free electrode, you can say, that is called. So in basic electrode generally used for very sophisticated types of purpose. I have already told you. There it is, you can see. And this flux has some specific features. You can use it in vertical overhead position also. Because this flux have a specific characteristic that is called viscous phenomena and other things, and it's a fast freezing types of flux. What I'm telling, understand? So
Yes, sir.
immediately after welding, generally it's freeze, solidify. So what happens? Your molten droplets cannot fall down. What I'm telling, understand? So these types of each and every flux have some specific features. Or depending upon our requirement, generally we develop all these things. Our researchers developed all these things. Nowadays also, so many research work is going on this electrode and its flux. You can't imagine. So depending upon, you see, wherever there will be need, wherever there will be requirement, there will come research. And from there, research only some new things is developed. What I'm telling, understand?
Yes, sir. Yes.
Okay, bhai. Any other questions?
Sir, we are having different like diameters of electrodes,
Yes.
and how can we select the current and voltage for that?
Very good.
So like
So
particular.
you see, I have already told that things.
Sir, you
How
can
this?
share the screen.
Yeah, I am
Now
just sharing.
your video is clear, your voice is clear.
Yeah, okay. I am just sharing this screen, by. I am sharing. Okay, very
I,
good. 1
yes.
minute. 1 minute. I am sharing. Yeah, actually, I have already told you that you can say that 1 minute. Here, one thing you should keep it in mind. Just 1 minute. This is the screen I am sharing. I am not drawing anything. Okay. If I'll draw, then actually I'll show that thing. So you see what I told. Generally, everything is depends on some law. That law is based on some practice, and it's what it's called. Law is based on some, you can say, some experience. Whatever the likes, Ohm's developed a law. What is the Ohm's law? You see,
P equal to
resistance is directly proportional to length,
length
and
and
resistance is inversely
proportional to
proportional
area.
area. Very good. So this law is coming not arbitrarily. What I'm telling, understand?
Yes,
To finalize or to formalize this law, he did so many research, you can't imagine. Finally got that things only. Now you told me that, okay, sir, for higher diameter, if the diameter of this electrode will be higher, then resistance will be more or less. You tell.
more, sir.
Resistance
Because
will be less. Inversely proportional, na?
okay. Because the area of cross section increases,
Increases, then what happens? Your
then
resistance
resistance
will be
decreases.
resistance decreases. On resistance decrease, then you know heat generation Q is equal to I square R.
Yes, sir.
Okay,
I
so
square
it's
RT.
directly proportional to R. You can say heat generation is directly proportional to R.
R.
So you
Yes, sir.
see, if your diameter of the electrode is more, then your heat generation for same current will be reduced.
Yes, sir.
तो क्या करना पड़ेगा? What you need to do then? Then to increase the heat input, you need more current. So higher the diameter of the electrode, then due to less resistance, you need
Higher than
to increase the current. Then only will get required amount of heat to do the appropriate welding. What I'm telling you, understand? You got my point, right?
Yes, sir.
Lakshmi?
Yes, sir.
That is the thing. That is the fundamental. Actually, that's why you see these things you should keep it in mind. Okay. So the things you need to know, the fundamental things.
Right, sir. Right, sir.
So you see now you got the idea. Now you can play. What should be the things? What should be this thing, that thing? So now you are doing some welding operation. So you are getting that, okay, electrode is not properly burning, electrode is not this thing. Then you understand now what can be the reason behind this. Clear? Why?
Yes,
So
sir.
you can play by your own. Okay, because if you know the fundamental things, whatever the things you want, if you want more deposition, you need lesser welding speed. If you want more deposition, you want high heat input. So to get high heat input, what are the things required? Everything is now known to you. Now you can play. Okay, like that, only generally different parameter coming, and the different parameter we decide for different types of material, right? Okay,
Right,
clear?
sir.
Yeah.
Yes, sir.
Any other questions? Lakshmi? Lakshmi, you are from which place?
Sir, I'm at Punjabi University, Patiala.
Very good, very good. Okay, bhai.
Actually, sir,
Hazik also. Yeah,
one more thing I want to ask.
yeah,
That
definitely.
in our welding lab,
Huh.
actually, they are practicing V groove
B group, very good,
for making some butt joints.
very good.
So they are making double V grooves in
Hmm.
just 5 millimeter MS plate. So
5
I think this
millimeter
is
MS
wrong
plus
practice.
5 millimeter MS plus double V, both side.
Yes,
Oh
yes,
my God.
that's what I am asking you. I think this is the wrong practice, na, sir?
Wrong practice, definitely. But depending
Because
upon your
this
no,
needs
but
more than
yeah,
10 millimeter.
but here one thing you should keep it in mind. Depending upon your type of welding, it varies. What I'm telling, understand? What types of
Yes.
welding technique they are using? That is a very important thing. Like
In
what happens?
simple electric arc welding, they are doing this
Electric arc
practice.
welding, then it is a very wrong practice. That is
Yes,
very
yes,
that is
yeah.
not
That's why.
required at all. What I'm telling, I understand.
Yes, yes. That's
Because
what I
depending
think.
on, let's what happens, you are doing very precision welding where the electrode diameter is very thin. What are, let's 1 mm thin diameter electrode or less than 1 mm diameter electrode. That case, generally you can use some sort of these types of thing for even thin section. But for SMAW and submerged arc welding, MIG welding, it's not required at all for 5 millimeter thing. Even V group. You can't imagine nowadays we are doing without any S preparation welding in case of submerged arc welding. In case of MIG welding, we are doing without any S preparation. That means in a square S preparation only, we are getting thickness range from 12 to 14 millimeter for SMAW, what it's called MIG welding process. Similarly, submerged arc welding process, we are doing that thing for 16 to 20 millimeter thick plate without any preparation, only a square is. What I'm telling, understand? We are doing the welding and we are getting very nice with single run, very nice quality welding. You can't imagine, right? So that is a
Right.
wrong practice that you can say. They are doing
Yes,
wrong
yes,
thing, right?
yes.
That is not required at all.
Actually, I want to tell them, but
Uh,
actually they are not understanding. They have made their experiment like they
Actually,
are making
that is
this.
the thing. That is the thing. Actually, what happens? Whatever the things they learn from the beginning, they generally try to utilize those things throughout their whole life. They don't want to listen anybody. That you can say. That's why if you will be expert in welding, na, and if you will be in very good position, then only you can do something, you can change something in industry. Hassan, tell why?
सर ये जो टिक वेल्डिंग में फिलर वायर यूज करते हैं तो कैसा सिलेक्शन करेंगे 304 304L 308L
Yeah, why? बोलो कौन सा yeah, you tell me. You are asking for TIG welding.
टिक वेल्डिंग फिलर वायर
TIG welding, very good. You see, I have already, you see, just last module, you can see that is called generally welding defect and inspection. Okay. So
Yes,
in
sir.
welding defect and inspection, you will find a topics that is how we can select the electrode and flare wire. What I'm telling, understand?
Yes.
For a particular types of material, particular types of flare wire are there. What I'm telling, understand? That is called compatible flare wire. That means for a
Yes.
particular material, you can use, let's for aluminum material, you can use steel types of flare wire. You can't use that thing. For aluminum, particular types of flare wire is there, which is that flare wire has a composition which is very compatible with that aluminum. What I am telling, understand, Hazak?
Yes.
Yes.
So depending upon your type of workpiece material, you should decide your filler wire. What I am telling, understand, why? If you use steel, if for steel material, what types of steel you are going to join? For that types of material, you have a specific types of filler wire. What I'm telling, if you will not use that filler wire, your welding will be defective. That's why in welding defect and inspection module, you will find how to choose, how to decide a filler wire for a particular types of joint material. What I'm telling, and for a particular types of workpiece material. In detail, I explain over there. You can arbitrarily choose the filler wire and do the welding. Then your welding will not be there proper. What I'm telling, understand, why? Very good question. Ajak.
बट सर जो एसएस है ना स्टेनलेस स्टील वेल्डिंग करते हैं जैसे 304 है 308 है 308L है तो मैक्सिमम फिलर वायर यूज करते हैं 308 का ही यूज करते हैं क्यों?
हाँ देखो, that means 308 ऐसे एक फिलर वायर है. As you are talking in Hindi, that's why I am also talking in Hindi. As you are using 308, because 308 material, you see SS na, what is stainless steel have? Stainless steel have more or less, all the stainless steel have more or less same composition. What I am telling, and that's just minor change of different composition as there.
Yes, sir.
Depending upon that thing, generally your filler wire, your SS has different name. What I am telling, understand?
Yes.
But always you should keep this thing in mind. Stainless steel means once the composition, that means stainless steel means once the chromium percentage is more than 11.5%, you can say. Then what happens? A shiny stain layer is generally developed on the steel plate. What I am telling, understand? That shiny layer or a stain layer generally protect your workpiece or steel plate from atmospheric contamination. That means from corrosion. That stain layer is generally, depending upon that stain layer, your stainless steel terminology comes. What I am telling, understand? So this stain layer, when it forms, this stain layer is formed when the percentage of chromium in your that material is more than 11%. That you can say approximately 11%. Below that, generally a stain layer does not form. That's why generally approximately 11% is considered. So that's why above 11% chromium with some other composition. So what happens? Most of the stainless steel have a proportion of that types of chromium, nickel, and other magnesium, whatever the other composition are. That generally minute, it's buried, and it has different name. What I'm telling, understand? So 308 have a composition which is more or less, you see, composition which is more or less similar to all other material, that you can say, which is not creating any problem because it has a minute change. What I'm telling, understand? That's why 308 can be used very widely. What I'm telling, understand? Clear,
जी
Hazak? That is
सर
the thing, right? But what
सर
happens for
एक डाउट और
stainless
था
steel? If you go for using aluminum types of electrode, your thing will not
जी
work. What I am telling,
जी
understand?
सर
Yeah.
एक
Tell,
एक और
right?
डाउट था सर
बोलो.
सर जैसे अपना 300 mm का डाया है वो फायर वाटर पाइपलाइन है तो उसमें जो
हाँ.
रूट गैप है वो टिक वेल्डिंग से करते हैं फिर इसके बाद SMAW करते हैं तो क्या रूट
हाँ.
गैप SMAW से नहीं कर सकते क्या
क्यों नहीं तुम कर सकते हो? Whatever the things you want, you can do. What I am telling, understand?
जी
TIG welding से करने पे क्या होता है? Generally precision. That means root gap should have some appropriate dimension. Root gap का ज्यादा बड़ा और ज्यादा छोटा variation रहेगा तो your welding will not be proper. What I am telling, understand? So to
जी सर
maintain a very uniform root gap, it is better to use TIG. Then TIG is considered as a very precision welding technique, right? What I am telling,
जी
understand?
सर
If you use
सर जी
SMAW, then there is a chance of what happens variation because SMAW that control and it's not that much of precision like TIG welding process. What I am telling, understand?
जी सर
That's why it is
जी
better
सर
to you can use.
जी
But where generally you don't want mass precision and other thing, there you can use. But you should always keep this thing in mind. For a
जी
particular types of thickness, particular types of root gap is required. Okay.
जी
To maintain that root gap, you should use a very precision types of welding technique. That is better to use. What I am telling, understand, right?
जी सर
Yeah.
तो जैसे सर उसमें डिफेक्ट जैसे कुछ आ गया टिक वेल्डिंग जैसे करते हैं रूट गैप में
हाँ.
तो उसको कैसे रिमूव करेंगे जैसे उसमें
Very
टंगस्टन
good.
इंक्लूजन आ गया
Very good. You see, let's कुछ डिफेक्ट है. लेट्स कुछ क्रैक जनरेट हुआ तो उसको
जी
रिपेयर कैसे करता है? दिस इज वेरी
जी
गुड
सर
क्वेश्चन. So in welding defect and inspection, I have already explained that things. Always you should
जी
keep it in mind. Wherever there is some crack, some inclusion and other things, what you need to do, you should remove that portion. For removing this portion, generally, what you can do, there is some operation that is called gouging techniques. You know, have you heard the name gouging? Gouging technique means some burning effect is required to put there, and you should remove that, extract
एक
that
बार
portion.
बोलो सर
Yeah.
प्रोसेस क्या है
Huh?
एक बार हिंदी में बोलो सर गाउजिंग प्रोसेस जो आप बोले क्या है
गाउजिंग प्रोसेस
थोड़ा
क्या
सा
होता है? गाउजिंग प्रोसेस में क्या होता है? जहाँ पे क्रैक हो गया ना, उस क्रैक पोर्शन में जनरली एक हीट करके उस क्रैक पोर्शन को रिमूव कर लेता है भाई. रिमूव करने के
ओके सर
बाद फिर अच्छा मटेरियल देके उसको फिल करना पड़ता है.
जी सर
क्या बोला सर? फिर नया तरीके से उसमें वेल्डिंग करना पड़ता है. ये रिपेयर
जी सर
करने के लिए रिपेयरिंग टेक्निक ऐसे होता है भाई. ठीक है.
सर
और भी डिफरेंट टेक्निक्स है. Okay, once you will just go through my welding defect and inspection, you will get the detailed idea. Okay.
जी
Okay.
ओके
Any other
सर
question?
अभी तो कुछ भी
Very
नहीं है सर
okay, very thank you, Lakshmi. Thank you. I think no other queries are there.
सर एक
So
और डाउट
yeah,
एग्जाम
tell
रिलेटेड
भाई.
डाउट था मुझे
Yeah, tell.
जैसे अभी तो सर मैं इंग्लिश मीडियम से नहीं पढ़ा हूँ तो मुझे तो इंग्लिश नहीं आती है उतना
हाँ.
मैं इंटरेस्टेड हूँ कोर्स करने के लिए बट मैं एग्जाम दूंगा तो वो तो पूरा इंग्लिश में आएगा ऑलरेडी मैं तो गवर्नमेंट एम्प्लॉय हूँ सर एज ए
अच्छा
टेक्नीशियन
भाई.
पोस्ट पे हूँ
अच्छा. ओ, तो जनरली तो NPTEL वो जो हुआ मीन्स ऑर्गेनाइजिंग कमिटी, दे कैन ओनली टेल दिस थिंग भाई. दे definitely can help you. What I'm telling, understand? I don't have much idea about this thing, right? Haji,
जी सर
I think definitely they will help you
जी सर
if you
बट
just
हिंदी में
request
थोड़ा
them, right?
तो भी थोड़ा कोर्स का एक थोड़ा बढ़ावा मिलता उनको
वो
अभी
तो
जैसे
सही,
मैं हूँ
वो
पूरे
तो सही है.
तो मैं तो करने के लिए इंटरेस्टेड हूँ बट इंग्लिश में पेपर आएगा तो इंग्लिश आप जो बोलते हैं वो मैं समझ जाता हूँ लेकिन मैं लिख नहीं पाऊंगा बोल नहीं पाऊंगा
लिखने का नहीं भाई, यहाँ पे पूरा तुम्हारा MCQ टाइप का ही क्वेश्चन होगा. हाजी,
समझना ना सर थोड़ा भी इधर उधर वो हो गया तो गलत रंग हो जाता ना
I think definitely they will clarify your doubt whatever during the exam time. Definitely, if you just request them, definitely they will clarify your doubt.
वही तो
That I can.
ऐसा कुछ पॉसिबल रहे तो सर मैं
Actually, you can contact with them, right? I don't have much idea about this thing. Okay, I am not very clear about this thing. It is better you contact with that NPTEL group. Okay, they definitely will help you. Why? I don't have much idea about this. Okay, generally till now, whatever the exam happened, each and every exam generally happened in English medium only.
जी सर।
Okay.
तभी अभी मुझे कैसे करना सर, जैसे मैं करना का चाह रहा हूँ तो
You will get the definitely help. Definitely will get help because they are there to help you people only, right? Like me in live session, I am sitting here for such 2 hour times, na, for helping you people to clarify your doubt and all the things, na. Similarly, they
सर।
are there to help you, right? These one
जी
things I
सर।
can say.
जी सर।
Okay.
ओके सर,
I think no
थैंक
other
यू सर।
questions are there. Thank you, Lakshmi. Thank you so much. You can
Okay, sir. Thank you,
directly
sir.
you can directly contact with me also.
Yes,
You
sir.
have my what it's called mail ID, even contact number also. So
Yes,
directly you
sir,
can
contact
call
number,
me.
sir.
You can this open forum. I will not share my contact number, but you just mail me. I'll then share you. Okay, right?
Okay, sir.
In
Okay, sir.
official mail ID, you can share me your mail ID. Send me a mail. I'll share you my
Yes,
contact number. Right? Thank you.
Okay, sir. Okay,
सर
sir.
जो
I
Okay, sir.
think हाँ बोलो
सर
भाई
जो हीट अफेक्टेड जोन्स
हाँ
हैज, इसमें
हाँ
जो माइक्रोस्ट्रक्चर चेंजेस होते हैं
हाँ
वो थोड़ा आप बताएंगे सर?
very good. That is a very good question. Though
हीट
this is
अफेक्टेड,
not, yeah, I'm just explaining this thing. Though this is not a part of this course at all, this fundamental of welding science and technology, then also I'm explaining little bit.
and
And yeah.
how much part we can say that it is like called as has?
Yeah,
From
I
the
am just telling. I am just telling. Why I am telling. One thing you should keep it in mind. I think you have already very well familiar with iron carbon diagram, TTT diagram. This diagram, two diagram, you know, Lakshmi?
actually we know, but we forget, sir.
So that is the
That's the
things actually, right? So
right.
if you know that thing, then it will be very clear to you what are the things happen there. This just you go through this TTD diagram and iron carbon diagram, every idea will be clear to you. If you will have any doubt, then you can ask me, I will clarify your doubt. Then also I am explaining little bit. Heat affected zone, what does it means? That means here the microstructure is affected by heat. What I am telling, only heat. Due to
Yes.
heat, what happens? Here generally no melting, no what happens? Melting types of phenomena is not there. During solid state condition itself, microstructural changes occur. What I am telling, understand? That's
Yes.
why you can see in iron carbon diagram there are different critical line. Lower critical line, upper critical line, this critical, that critical. What I'm telling, understand?
Yes, sir.
So just little bit go through this thing. So in case of steel, iron carbon diagram, you observe that generally 723 degrees centigrade is generally considered as lower critical,
Yes.
that means recrystallization temperature of steel. What I'm telling, understand?
Yes.
So recrystallization. So once a material below this temperature range, then what happens? It is not affected by heat. That means no microstructural change generally does not taken place in case of steel material below that recrystallization temperature. What is recrystallization means? Recrystallization means crystallization again occur. Recrystallization. That means
Means new
crystal
grains.
formed. New
Okay.
crystal formed, right? So
Right.
once something goes above this temperature range, then
Right.
there will be change of what it's called crystal. What I'm telling, understand?
Yes, sir.
So once crystal change, then your microstructural changes occur. So heat affected zone means you can say below melting point to a temperature around 700 degrees centigrade temperature. This range, in this range, you will observe there is a change of microstructure which is different from parent material, base material. What I am telling, understand? Similarly, in melting zone, you will get some other types of microstructure. So this iron carbon diagram and TTT diagram, once you'll go through very clear way, you will get every idea clearly. What I'm telling, understand? I'm sure. You go through this, right? Clear,
Yes.
Lakshmi?
Yes, sir. Yes, sir. Fine.
Okay. These one things actually, okay, fine. I think no other questions are there. Time is also up.
Sir, is there any next meeting?
I think you can, I think for this course, no other further sessions are there. Only 2 sessions generally for a particular course, a 8-module course. Okay.
Right. This is
Okay,
your
right?
second meeting.
Second, right? So I think no other these things, no other live session will be there.
Numerical portion कितना आएगा सर उसमें exam?
Numerical portion you can consider around 1/4 of around 20%.
So like we can accept numericals like duty cycles and sir duty cycle and
Duty cycle, then optimum power, so power calculation, efficiency, different portion are there. Heat generation, then physics of welding. Okay, Lakshmi, you can share me your contact number. Do you have your contact number?
yes sir 95
95
0
0
18
18
7
7
55
55
00 sir.
00. Thank you, bhai. I will definitely this your one contact number, na?
Yes sir.
Okay, fine. Okay,
Right.
thank you so much. Okay, if you have
Thank
any
you,
queries,
sir.
anything, you can directly contact with me. I will just call you, right? Okay.
No sir, by listening your lecture actually we are getting a great knowledge. Very fundamental.
Thank you so
Something
much, Lakshmi.
we don't use to understand from the book, sir. Whatever you
Thank you,
teach,
bhai.
that is very great and very point to point clear.
Thank you for your compliment. Okay, bhai. Thank you so
Yes,
much.
sir. Great. Thank you.
Okay. Thank you. Hello. I think there are no other questions, so we can leave. Shall I leave, bhai? Hello.
हाँ जी सर ठीक है सर.
Okay, ठीक है.
हाँ
Oh,
मिलते हैं. Fine sir.
okay, I'm leaving.